Welcome to Intro2Astro 2024.
Last topic for today is the so-called NASA Exoplanet Archive. And well, Rena has just shown you the various exoplanet detection method. Now let's take a look at the real planets that are found by these various techniques. So the NASA Exoplanet Archive is actually an online database maintained by NASA and contains the useful information on individual planetary system as well as on the whole population of known exoplanets. Yeah, this is a database, but the facade is just a website. And let's walk through some of the key features. So you can see the website reports the latest number of confirmed planets. That's 5,678. And that was updated, I think, 3 weeks ago, June 25th. And they also list some of the planets found by the latest NASA mission. For example, this one, the TESS mission. This is one of the most important missions that NASA is running as a transit mission, as Rena mentioned. And it also has planet candidates. By candidates, what we mean is that these are most likely planets, but we haven't confirmed them through, say, mass measurement. So, the current standard for confirming a planet is either you have measured the mass of the planet, or you have ruled out all possible false positive scenarios, including eclipsing binaries. And usually, these follow-up observation takes some resources. And people are hard at work confirming planets, but it is almost always the case that number of candidates will outweigh the number of confirmed planets. And you can click on all of these, and it will take you to a table that lists the key parameters of the systems. For example, the planet name of the host star. Well, these are some bookkeeping things like the parameter sets, number of stars. Some stars can be binary or triple star systems, number of planets. You can see some planets, some systems have multiple planets. For example, this one has 2 planets. The discovery method, as Rena mentioned, whether it's transits, radial velocity, imaging, microlensing. Year of discovery facility, which is a telescope that we use to discover the planet, for example. Keck is a telescope in Hawaii that our team use a lot. And many of these are actually from space-based facilities like TESS and Kepler. We'll talk about TESS in more detail later in the course. And yeah, you can go through the table. It also provides the reference or the original paper that published these planets. The orbital parameter, semi-major axis, planet radius, planet mass, a lot of things. Okay, let's go back. So a key feature of the archive is that you can type in the name of your favorite system. So one of my favorite system is TY 1136. The reason why I'm interested in it, this is actually a system discovered by our group. There's 6 planets that you can see here. The host star is a sun-like star, almost exactly solar radius, 0.98 solar radius, and an effective temperature pretty close to sun too. But the planets are quite different from our solar system planets. So by the way, planets are named with lowercase letter from B onwards. So the planets are named B, C, D, E, F, G for the 6 planets. The reason I picked this system is that the system is very peculiar in the sense that all the planets are within the orbit of Mercury. For example, the longest period planet, it only has an orbital period of about 40 days. In contrast, our Mercury, which is our innermost planet, has an orbital period of 88 days, which means that all 6 planets are packed compactly within the orbit of Mercury. And what could have given rise to such a compact orbital architecture is still active research. So that hopefully gives you a glimpse of how to look up the information on individual system. So there's a reference here. If you click it, it will take you to the NASA ADS system that we talked about in week 1, and you can check out the paper. Okay, so coming back to NASA Exoplanet Archive, another useful feature is that it periodically reports the latest news in exoplanets. For example, this page is reporting Gliese 12b and Specular 3b, which are 2 Earth-sized planets nearby, and they are very favorable for follow-up observation. Another key feature is that Exoplanet Archive also produce these so-called pre-generated plots. So let's maybe look at some of them. So the most commonly used one is this one. This shows the mass of the detected planet versus the orbital period. And the different symbols represent the different detection methods. For example, radial velocity, transit, microlensing, imaging, transit time duration. Some of these we have talked about. So the key thing you can see is that the various detection methods tend to discover planets in different part of the parameter space. For example, the transit method tend to detect the shorter period planets, those with orbital period less than 100 days or so. Whereas the radial velocity method, which again is measuring the mass of the planet, these tend to discover planets that are more massive, typically at least 20% or 30% of Jupiter mass. Yeah, so this table is almost updated daily. So you can see this was generated in July 15. Okay, so let's go back to the pre-generated plots. So there are a whole bunch of other related plots, for example, period versus planet radius, the year of discovery. You can see there are 2 years that are particularly prolific in terms of number detection. This is 2014 and 2016. And I think both of these correspond to a large data release from the NASA Kepler mission, which is a workhorse for the transit detection about a decade ago. Okay, so the other plots, we'll go into making some of these plots shortly, but just want to alert you, you can directly borrow these plots. All right, so coming back to the NASA Exoplanet Archive. So in this part of the website, you can look at the various planets discovered by the different missions. So I mentioned TESS, which is ongoing NASA mission. Kepler is kind of the predecessor for TESS. And K2 is the extension of the Kepler mission. KELT is a ground-based mission. Similarly, Euclid is also a ground-based mission. And there are other useful tools. So I won't go into detail of these today, but if you ever end up working in exoplanet research, some of these tools are very useful. Okay, so I think that was a quick overview. Let's take a look at the Python notebook that accompany the Exoplanet Archive. So let's make use of the various knowledge we have picked up in the first 3 weeks. So let's first import some of the useful package. OS is a system for handling, directory saving files. Pandas, we have examined this package. This is for handling a large table of data. NumPy, this is usually for handling data and quick mathematical operation. And Joshua has just covered matplotlib, which is used for making plots. And this is a subfunction in matplotlib, so-called inline. This is allowing the plots to appear between the different Python or the Jupyter cells. This is very handy for displaying the plots in time. Okay, so let's make use of the data from NASA Exoplanet Archive and make a mass radius diagram, where the horizontal axis is the mass of the planet and the y-axis is the radius. So this cell basically tells the code where our saved data is located. It's in a folder called data, and the file name is called confirmexample.csv, where CSV stands for comma separated. values, a commonly used format for storing data. And we use Panda to read the data, which is simply in this function read CSV. And all you need is to provide the path to the file and a comment. This is removing the header of the file. And now we are displaying the first 5 entries of the table. You can see, again, this is what we saw earlier, the planet name, the host name, the discovery method, the orbital period, etc. So a useful tool in Pandas is that you can tell Panda to display the shape of your data. This is basically called this is basically done by dot shape, and you can see we have 762 entries, and each entry will have 72 columns of different values. Okay, to make a mass radius diagram, we have to know that mass and radius are respectively named PL_B mass. J stands for Jupiter. So the mass and radius are known units of Jupiter, and we can easily use the function that Joshua has just shown us, which is plt.plot. And this is exactly what we mean by mass radius diagram. You can see that here the data is not very clear. Some of the data are really clumped together. One way you can clear up the data, the plot, is by using a log scale, which is simply by calling the keyword x scale and specify it as log. Now, all that 762 planets are shown here, and you can see they span somewhere between 0.1 Jupiter radius to about 2 Jupiter radius. And the mass spans 1,000 of Jupiter, which is closer to Earth. Earth is about 3.3% of Jupiter mass, all the way up to about 10 Jupiter mass. Note again, 13 Jupiter mass is the upper limit. Anything larger than that will be classified as a brown dwarf rather than an exoplanet. Okay, so let's look at another example plot, which is visualizing the radius distribution of all the transiting planets. So I have pre-downloaded data, but you can do the same by going back to the NASA Exoplanet Archive. Again, reading the data using pandas and displaying the first few headers of the table. And now we are making a histogram rather than a scattered plot of the radius. And again, you can see most planets have a radius below 10 Earth mass, 10 Earth radius, which is right about Jupiter radius. And we can also make the histogram more clear if we do it, or if we bin things in a log space. Okay, so the assignment for this part of the workshop is for you to make orbital period versus radius diagram for all the transiting Kepler planets. And this can, again, be downloaded from the NASA Exoplanet Archive. Let me just quickly show you how to download the data. So if you go to the table here, there's an option to download data, and you want to select CSV. This is usually the easiest to manipulate. And you can specify to download all the columns or currently selected columns. And you click this button, download table. It will be saved on your local machine. Usually the website is pretty quick. Okay, so the final part of the assignment is to make a plot of whatever 2 parameters you want. Pick and choose and see if you can discover something using the known exoplanetary population. Okay, that's all. Let us know if you have any questions. Well, I haven't been monitoring the chat. Is there any question already? So Akriti asked, does the NASA archive have already discovered planets? Yes, all of these are discovered planets. If you want to discover something new, you have to use the raw data from, say, for example, TESS. And we will show you how to do that later in the workshop. Okay, looks like Rena already has answered a few questions. All right, folks, any other questions before we end? Yeah, so one thing I forgot to mention is that NASA, or for example, Harvard or Cornell, some of the big organizations, they help to contribute to community by maintaining these online database. NASA Exoplanet Archive is one example. Later, we will see other example, for example, the TESS database, the Gaia database. So as a researcher, you will learn how to access the data on various databases. And the demonstration we had so far was one of the ways where you can use the database. Another way is to write an API or directly using the code interface to access those data. And those tend to be faster. We'll show you how to do that later.
Register now on bit.ly/Intro2Astro 2024.